This is lesson 52 on shifters. Now we've seen shifters before in the context of doing our binary to BCD converter, you remember. But here I show a shifter with a 4-bit input and a 4-bit output, and we have 3 control lines, much like you'd have in a multiplexer. And depending on the values of S2, S1, S0, we'll have this shifter shift different amounts. For example, if S2, S1, and S0 are all 0, then there's no shift. That is, Y3 gets D3 and Y2 gets D2 and so forth. So it's just exactly the same. If we make the 3 control lines as 0, 0, 1, then we shift right 1 bit, and we'll sort of pump a 0 in from the left. So Y3 becomes 0, then Y2 gets D3, Y1 gets D2, and Y0 gets D1. See, they just get shifted over. If we make S a 2, we'll shift left. That is, D2 goes to Y3, D1 goes to Y2, D0 goes to Y1, and we shift a 0 in from the right. A value of S2, S1, S0 of 0, 1, 1, that is a 3. We'll do a rotate right. Rotate right means take the D0 and rotate it around, and that becomes the new Y3. And then D1 goes to Y0, D2 goes to Y1, D3 goes to Y2. So you end up with D0 and then D3, D2, D1 as the output. Value of 4 for S will be a rotate left, just the opposite. D2 goes into Y3. What was in Y3, that is a D3 goes around, so it shifts, so you end up with a D3 on the right, and then D0 goes to the output Y1, D1 goes to Y2, D2 to Y3. So that's rotate left. A 5 for S is an arithmetic shift right. Arithmetic shift right differs from this shift right, which is really a logic shift right where we pump a 0 in. Instead of pumping a 0 in, the arithmetic shift right keeps the sign bit the same. So D3 is the sign bit, so that stays the same, D3, and then they all get shifted over. So the D3 gets shifted over, so if it was a 1 it stays a 1, but then the 1 gets shifted over, and then D2 gets shifted over, D1 gets shifted over. So that's arithmetic shift right. For 6 I put a rotate 2 where we shift, we're going to rotate 2 bits, so D0 goes over here and ends up at Y2, D1 rotates around and ends up at Y3, and then D3 shifts 2 bits over here to Y1, and D2 shifts 2 bits to Y0. So that's just a rotate 2. And for 7 we left it as no shift again. Now in the next lesson we'll actually implement this in VHDL, but now I want to show you a VHDL function which is very useful for shifting. Here I show a shifter with 16 bits coming in for D and 16 bits coming out for Y, and we'll have a bit called left-right, which will, if it's 0 will shift left, and say if it's 1 will shift right. And then we have a shift count. I show it shift count 7 down to 0, which is going to be the number of bits to shift. We don't really need all the 8 bits for 16 bits, but I just show it as 8 bits here. And here's the built-in function. This function is built into your unsigned VHD arith library, so same one that you use for the plus and minus. So you have to include that. But now you can say Y gets shift right D comma shift count. This will shift D right shift count bits. So this is the number of bits you shift. And to shift left, you say Y is shift left D comma shift count. This will shift D left shift count bits. So this is very useful. here's a VHDL program which will do it. We make a shifter. D is 15 down to 0, 16 bits coming in. LR is our little left-right control. Shift count is the input, 7 down to 0. And Y is the output, 15 down to 0. And here's what you can say. You have a process, D, LR shift count, and you say if LR is equal to 1, then Y shifts right, D comma shift count, else Y is shift left, D comma shift count. So if LR is 0, it'll shift left. If it's 1, it'll shift right, and it shifts it shift count bits. So this is very useful.